So basically, we're looking at the rules of exponents. In the textbook our students use, it's in 5.1. But this is a principle you need to know no matter what textbook you use. And the idea is an exponent is this thing up there, right? You have a base and you have an exponent. See, the beauty of math is you can take a problem like this, 4 times 2 squared. You could change the 4 to 2 squared. So in this problem, it's basically 2 squared times 2 squared. According to the rules of exponents, you can add the powers, and that's why this becomes 2 to the 4th power. That's how we do number 3 from the practice problems. Let's look at a few more examples. Look at this problem, 3m times 4mn. You can move the 4 around, and that's because of the commutative property of multiplication. You're allowed to move things around. So 3 times 4 is 12, and then the m's are next to one another. They become m squared, and then the n is by itself. So basically this problem is 3 times 4 and then m times n, so it becomes 12m squared n. Okay, that's number 5. Number 7, we basically have 2m to the 4th times n squared times 1 and m. The 1, by the way, just forget it. Anything times 1 is itself, so you don't have to worry about the 1. Now we're going to move the m's next to one another, m to the 4th, n squared, and then we have n squared and n. So when we have this problem, we basically can add the powers here to get m to the 6th, and we can add these two and we get n to the 3rd. An exponent a base without a power showing is the same thing as that base to the 1st power, but we don't always write that down. We don't need to. We can save on ink, and then we basically know that it's n squared times n to the 1st, which is n to the 3rd. That's how you do number 7. Okay, that's how we tackle number 7. Let's look at a few more examples. Number 9, 3 cubed with a 4 outside. The rule says, according to the rules of exponents, when you have something a power here times a number out there, you multiply those two together and you get the 12. That's how we get 3 to the 12. Okay, over here we have 4 to the 4th with a squared. These two can multiply and it becomes 4 to the 8th. That's what happens for that particular problem. Next, we have 2 to the 1st power, u to the 3rd, v squared, and a square. This was just written as a 2, but we know that there's a 1 there. And according to the rule, this power multiplies everything inside, and that's how we get 2 squared, u to the 6th, and v to the 4th. The answer here can also be written as 4, u to the 6th, v to the 4th. Okay, last two problems. Here we have 4 outside, so it multiplies the power there, it becomes 2 to the 4th. It multiplies the power there, it becomes 8 to the 16th. That's how we solve number 15. Number 17. 4 to the 5th power divided by 4 cubed. That leads us to another rule of exponent. If we have the same base, we can subtract the powers, and that's what we did. 5 minus 3, that's 4 squared, and that's how we solved that particular problem. Some great Bible verses there. Some students are working with a mentor earlier on, and so I just left one of the verses they were doing, and then the other two are talking about spiritual gifts. So let me know if you have any questions, but that is how you work through these problems for rules of exponents. Take care and have a blessed day.